Good morning, Grade 7. Welcome to WorksheetCloud, Grade 7 Natural Sciences. Yes, my name is Mrs. Hall, and I look forward to teaching you this lesson today. If you have a question during the lesson, send an email with your question to grade7@worksheetcloud.com. So, Grade 7s, before we get started, who of you have been lucky enough to have a birthday during the lockdown? Some of us might have had a fantastic celebration, and some of us might have just been wishing we could have celebrated a little bit more outside of our homes. So my daughter turned 19 and was planning quite a big celebration on the 19th of April. It's her crown birthday, yes, 19 on the 19th of April, and had quite a big celebration planned, and unfortunately lockdown got extended, so we had to come up with a new plan on how to celebrate her birthday. But you know what? Human beings are incredibly creative and ingenious, and we came up with a good way. We had a Zoom birthday party, which was also loads of fun. So Grade 7s, I want to wish you a very happy birthday if you've had to celebrate one during lockdown, or if you are still going to have to celebrate one during lockdown. I'm sure most of you are wishing that it will end before your birthday, but just in case, here's a happy birthday wish for you. So somebody else has a very special birthday, and the science geek in me had to bring in Albert Einstein. Yes. It's called Pi Day, and Albert Einstein was born on the 14th of March, 1879. It's a very special day to celebrate on the 14th of March because it's a very special number. Yes, 3.14. Who knows what that is? Yes, it's pi. So pi is the ratio of a circle's circumference to its diameter. So for any circle, if you divide its circumference by its diameter, you will always get the exact same number, 3.14 pi. Isn't that just amazing? An amazing man like Albert Einstein has his birthday on the 14th of March, which is 3.14. Isn't that incredible? Anyway, I have a little birthday surprise for you, so let's get going.
Narito na. Wimpo! Okay, pivotara. Pomelo? It's your birthday. It's your birthday. Happy birthday to you. It's your birthday. It's your birthday. Happy birthday
to you. So yes, Grade 7s, happy birthday to you. And on the screen, you will see that I have got happy birthday in 11 different languages. So see if you can find your language there and wish yourself a very happy birthday from WorksheetCloud to you. And while you're busy finding your language, I'm going to light your little birthday candle for you. Right, let's get the screen big. Okay, oopsie. There we go. Very happy birthday to you, Grade 7s, with love and best wishes for a really incredible year ahead of you. from Mrs. Hall and WorksheetCloud to you. So I'm going to blow for you and you make your wish, and know that I'm going to enjoy eating this chocolate brownie. I don't know if you can see it. There you go. That I baked for you. So happy birthday. Make a wish. And yes, grade 7s, the science geek in me says, did you know that scientists have discovered that birthdays are good for your health? The more birthdays you have, the longer you live. So have a happy birthday, and yep, the periodic table in the background. So as we say, happy birthday in English. Let me try it in Xhosa. Minimandi kuwe. I know that much. But happy birthday, guys. So let's get started with today's lesson on heat energy and its transfer. It's a continuation from conduction and convection, and today we are looking at heat transfer by radiation. So the objectives of today's lesson is to state that heat is transferred in straight lines in all directions by radiation, to state that heat rays are also known as infrared waves, and to give examples of the uses of infrared radiation. So let's start with our definition of radiation, grade 7s. So radiation is the transfer of energy through waves, electromagnetic radiation, or fast-traveling particles known as particulate radiation. Radiation can be in the form of heat, sound, and light. Radiation can be felt or seen like light, or detected through special instruments like an X-ray. The sun, the earth, the soil, and the microwaves that you have at home, television, cell phones, all expose us to some form of radiation. Electromagnetic radiation involves photons, energy that is always moving, traveling in waves, radio which brings sound to our ears, or like particles which are in X-rays. So if we look over here, heat energy waves or rays are known as infrared radiation. Infrared radiation waves will travel out from a hot source in all directions. Where do we experience infrared radiation? Just like light, infrared radiation can be absorbed or emitted or even reflected, and we look at that in a bit more detail later on. Your skin detects infrared radiation as heat, and infrared cameras allow us to look at how much radiation an object is emitting. All objects emit and absorb infrared radiation. Okay, the hotter an object, the more radiation it emits every second. So if you look over there, that house has a lot of heat coming off it at the moment. So heat energy from the sun travels to Earth by radiation. Sorry, I have to keep moving myself out the way. Since the space between the sun and the Earth is a vacuum, so if something is in a vacuum, it means no particles are present. The heat cannot travel by conduction or convection. Now remember, conduction is the transfer of heat through a solid, objects that are in direct contact with each other, and convection is the transfer of heat through fluids, in other words, a gas or a liquid. Okay. So, infrared radiation pictures can be transmitted using a special infrared camera to show the infrared radiation given off by different things. And there's an example of such a camera. So, This is an infrared image that you can see over here of a child's hand holding a lizard. And as you know, lizards are reptiles and they're cold-blooded. So look at the difference between the child's hand and the lizard and how much warmer the child's hand is depicted here compared to the lizard. So the purple is more cool and the yellow is obviously more warm. Here we have an infrared image of 2 coffee cups containing very hot drinks, and again you can see the warmth from the yellow color over there. Over here we have an image of a deer in the dark, and since infrared cameras detect heat radiation, they can see the heat from warm-blooded animals in the dark. This infrared over here picture shows a medical scan of an injured leg and a healthy leg. Okay, the bright white region shows the location of the injury. You can see it over there, which is warmer due to the increased blood flow to the injured area, because obviously the blood goes there to start trying to heal the wound. Right, this is an infrared image of footprints. As the person walks away barefoot, the heat left behind still glows on the ground. Here's an infrared image of a cat. The yellow areas are the warmest and the purple areas are the cooler part of the cat. Quite interesting, don't you think? An infrared image of a tire that has been heated by friction with the road. Okay. Notice how the area of the tire that touches the road glows much more brightly when you look through the infrared camera, because that is where most of the heat is concentrated. Here we have an infrared radiation picture. Again, this one is of a global sea surface. And it's showing us all the different temperatures. So infrared satellites are used to measure and track changing ocean surface temperatures to help us predict weather patterns. So radiation is used all day, every day in our lives, and we don't even know. When we're watching the news and watching to see what the weather's going to be like tomorrow, we didn't even know that radiation was used in order to predict the weather patterns. Right, so over here we have a very dull, matte, dark surface on this block over here, and here we have a much lighter surface. And basically you would have done experiments in class to try and determine which ones were better absorbers of heat, the dark or the light, or reflectors of heat, the dark or the light, or which one emitted heat more. Okay, so generally the dull or the matte dark surfaces are better absorbers of infrared radiation than the shinier lighter surfaces. Okay, so obviously the darker block will heat up much faster than the lighter block. If you lived in a hot country, grade 7s, would you paint your house a light color or a dark color based on this scientific evidence over here? Do you want your house to absorb more heat, or do you want it to reflect more heat? Okay, if you're living in a very hot country, obviously you want your house to be a lighter color. Also, what I thought I would share with you is fashion. Yes, in winter our clothes are much darker, and they're darker for a reason. It's to absorb the heat. And in summer we tend to wear much lighter colors to reflect the heat and keep us cooler. Look at this example of a vacuum flask. So a lot of you use this in winter to keep your hot chocolate in or your coffee in when you come to school. How does it work? How does it keep everything warm? Okay, so let's take a look. Let's move me there. So a vacuum flask has a double wall of silvered glass, with some vacuum between the wall. Okay, remember what a vacuum is? There's no particles there. Okay, so there cannot be transfer of heat through conduction or convection. Okay, the silvered surfaces reflect the infrared radiation from the very hot contents back into the flask, and that's how it keeps your hot chocolate warm. The vacuum between the outer and the inner walls prevent heat loss through conduction. Okay, so it's not able to transfer the heat through the vacuum. It is prevented. So, a quick quiz. Let's see who was listening. What direction does radiation travel? It travels in all directions, okay, in a straight line. Which will radiate more heat, black or shiny surfaces? Now, we're talking about radiating, not reflecting, giving off more heat, okay? The answer is a black surface. Which will absorb more heat? Again, the black will also absorb more heat. What's another name for heat radiation? You should all know this. Infrared. And give two uses for this radiation. Just think of anything we've discussed today that you might have thought of. Yeah, infrared photographs, remote controls, heat-seeking missiles, searching for earthquake survivors, chasing criminals, making toast. Yeah, you put your bread into that toaster and those radiant heat waves toast your bread. And keeping our homes warm. Yes, the fireplace emits radiant heat. Okay, so a little bit of a summary for you over here. We've got conduction, transfer of heat through a solid. Remember, it always moves from a hotter to a cooler, okay? And the objects are generally in direct contact with each other. Convection, the movement of heat through a fluid, so a liquid or a gas. And remember, the heat moves up and the cooler moves down. Okay, we spoke about density in quite a lot of detail. And then radiation is direct heat transfer. Okay, and another simple little diagram just to help you. There we have our conduction, and that's why this person is wearing a glove, because the particles vibrate and the heat travels along the metal rod, and eventually his hand will feel the heat. So you have to wear an insulator. Correct, okay? Here we have convection. Remember, warm air rises. So if we put our hands above the fire, we'll always feel the beautiful warm heat. And radiation, direct heat transfer through waves. Okay, remember, radiation cannot go through the air. It cannot go through a liquid. And obviously it's not direct contact, okay? So it generally doesn't travel through a medium, especially when it's coming from a fire. Okay, direct heat transfer there. So grade 7s, I hope you enjoyed this lesson and you learned something new. And I really hope that you have a very special birthday. I wish you best wishes now and always. May the year ahead be filled with many, many blessings. And for those of you who are waiting to celebrate, let's hope you are out of lockdown before your birthday. Have a good afternoon, grade 7s, and don't forget to download the worksheet. See you soon. Take care.